So let's apply Simpson's rule to integrate from 0 to 2 x squared dx. It's the same thing we use the trapezoid rule, so we can actually make a comparison between the two here shortly. And again, I'm going to use n equals 4 just like I did for the trapezoid. And obviously I want to compare it, and then I'll take the actual integration and figure out where we are. Okay, so just as a quick reminder, one of the forms for Simpson's rule is going to be delta x over 3 times f of x naught plus 4 times f of x1 plus twice f of x2 plus 4 times f of x3 plus yada 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 out to 4 times f of xn minus 1 plus f of xn. Sorry about that. Anyway, so that's the basic formula here. So I have n equals 4. So I'm going from 0 to 2. So delta x will be 2 minus 0 over 4. That's a half. And again, I draw a quick picture. Well, actually, I'm going to worry about is the x-axis. I'm going to 2, n equals 4. So I'm going to have the exact same values for x that I did with the trapezoid rule. And of course, over here, 0. So this integral from 0 to 2 of x squared dx is approximately equal to delta x over 3, that's 1/2 times 1/3 times f of x naught, well, x naught is 0, f of 0 is 0, plus 4 times 1/2 squared plus twice 1 squared, but it's 1, plus 4 times, hang on, we'll get rid of this. I don't think we really need this anymore. 3/2 squared plus, see there's 1, 2, 3. The last one was simply 2, so this is 2 squared. There's my 4, 2, 4 pattern. So this is going to be equal to, let's see, I have 1/6 times 4 times a fourth, that's 1, plus 2, plus 4 times 9/4. Obviously the 4s are cancel, plus 4. And so that's going to give me, what do I have here? I have 10 16 over 6, which is reduces to 8 over 3. Now remember the trapezoid rule, we said it was 11/4. Now what's the actual answer? Well, I'm going to go ahead and integrate from 0 to 2 of x squared dx. That's x cubed over 3 from 0 to 2. That's 8/3. It matches exactly with what we found with Simpson's rule. Well, in a way, that should not be a real big surprise because I use Simpson's rule, which uses a quadratic, to estimate a quadratic. So yeah, duh, it shouldn't be a surprise at all that I actually nailed that sucker. This 11/4 is actually not too bad, especially considering that I only had 4 intervals. If I increase the integrals or intervals, the number of intervals, I would get a closer and closer, to this 8/3.